we're going to learn to construct and interpret confidence intervals for the population mean mu. To do this requires that 3 conditions be satisfied. Condition number 1, the sample data come from a simple random sample or randomized experiment. So most of the data are going to come from random samples or from some form of an experiment. That's so you have the randomization aspect of the data. Your sample size must be small relative to the size of the population. That's the infamous, the sample size can be no more than 0.05 times the size of the population. And then lastly, either the data come from a population that is approximately normal, or you have a large sample size. If the data come from a population that's approximately normal, we know X bar will be approximately normal. If you have a large sample size, meaning n is at least 30, let's say, then we know via the central limit theorem that X bar will be approximately normal. So X bar has to be approximately normal in order to use students' t distribution to construct confidence intervals. If you were to do these by hand, this is the formula. X bar minus the critical value, which is a critical t, not a critical z, and then times s over the square root of n for your lower bound. Upper bound X bar plus your critical t times s over the square root of n. That critical t value is found using n minus 1 degrees of freedom. So if you have a sample of size 20, you're using 19 degrees of freedom. StatCrunch will do all that work for you. Okay?
Okay.
Yep.
So I'm going to just jump right to how we check this normality condition. When Gossett developed the t-distribution, he assumed the sample data came from a population that is normally distributed. Of course, most distributions are not exactly normal, so that condition has to be satisfied. How can we do this? 2 options. Option number 1, if your sample size is small, you can draw a normal probability plot. And then we get the correlation statistic for that normal probability plot and compare it to a critical value from a table that would be provided to you. And then the other thing is you have to use a box plot to check for outliers. That is the best way to verify your normality condition, is option number 1. There's a second option that relies on what's called the robustness of constructing confidence intervals. Robustness has to do with what happens to the method if I depart from the model assumptions, okay? And it turns out that the methods for constructing confidence intervals for a mean using students' t-distribution are fairly robust. So even if you don't have normally distributed data, the model still works pretty well. And so we're going to have 2 conditions here. Number 1, if your sample size is really small, like say less than 15, we'll construct confidence intervals provided the sample data are symmetric with no outliers. So your box plot would have to look something like this. Symmetric, meaning the median's in the middle, and each of the whiskers is roughly the same length. That's symmetric with no outliers. If your sample size is, say, at least 15 but less than 30, we're going to feel confident using this method, provided we don't have extreme skewness and no outliers. So, right here is a box plot that shows skewed to the right, but it's not all that extreme. So if your sample size is, say, 20, and you got a box plot that looked like this, you'd still feel pretty good using students' t-distribution. And then last, if your sample size is large, the central limit theorem says X bar will be approximately normal, and we can overcome any skewness in the distribution. So this option 2 relies more on judgment than option 1 does. We're going to construct a confidence interval about a population mean. We're going to once again use our Valentine's Day data. We are told that the data comes from a random sample. Well, we'll just assume it comes from a random sample of males. So let's review our conditions. We have a random sample of males. Our second condition is that our sample size must be small relative to the size of our population. Our sample size here is 12. The population size must, it's just males in general. I mean, there's 330 Americans in the US, about 150 million of them are males. So N is certainly bigger than even 100 million. So our sample size is definitely small relative to the size of our population. So I feel good about that. And then our sample size is small, so I have to verify the normality condition. If my sample size was bigger than 30, we'd be able to invoke the central limit theorem and the normality condition of X bar would be satisfied. So we will judge the normality condition here by drawing a normal probability plot and by drawing a box plot. So somewhere in here, I still have there's my Valentine's data. Remember how to draw a normal probability plot. You go graph and QQ plot. QQ stands for quantile plot. You select the amount spent. You add the correlation statistic, and we plot the normal quantile on the y-axis. Click compute, and there is your normal probability plot. And now I have to compare that correlation stat of 0.965 to a critical value. The critical value, if it's in a MyLab problem, the table of values will come up for you. For us, right now, what I'm going to do is go to our MyLab course and show you where you can find this table if you ever needed it outside of MyLab. So we just go into our course and we're going to select, it might be in the video and resource library, and then learning tools, and then formula table card. And if you scroll down far enough, you're going to see this table 6. There's table 6. Y'all see it? We have 12 observations, and so my critical value is 0.928. So 0.965 is bigger than 0.928. Therefore, the amount spent is approximately normal. Of course, I want to draw a box plot to verify I have no outliers. So I go back to StatCrunch here, select graph, box plot of the amount spent, use fences to identify outliers, and draw box plot horizontally. So this is amount spent by males on Valentine's Day. Click compute, and there you can see that I have no outliers. Notice that the median is left of center in the box and the right tail is a little longer, or the right whisker is a little longer than the left whisker, but that is not enough to say the distribution is not approximately normal. So I'll just drop that in here too. I'm just going to cover this stuff up. Okay, so we have no outliers. Now we can go ahead, because our conditions have been satisfied, and we can go ahead and use StatCrunch to construct our confidence interval. So now what I'm going to do is stat, t-stats, one sample, and for this problem I'm going to pick with data because of the fact that I have raw data. If I had summarized data, I would pick with summary. So here we go. Stat, t-stats, one sample with data. There's the with summary. With data, tell StatCrunch what column is in the data is in, and then select your confidence interval radio button, and then enter in your level of confidence. I think for this one, we wanted a 95% confidence interval. Nope, we want a 90% confidence interval. And so I'm going to change my level of confidence to 0.90. Click compute. Bada bing. StatCrunch provides us with the confidence interval. Of course, we want to interpret this now. We would say we are 90% confident the mean amount spent by males on Valentine's Day among those who spent is between $148 and 0.6, round to one more decimal than the raw data, and 196.3.